Hello everyone, welcome back to Let's Track JEE in English, the channel of Unacademy, and I am Jeetendra Dixit. Hello everyone, welcome back to Let's Here is my profile. So I did BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. I teach mathematics and today we'll continue differentiability. I've already taken one session of differentiability and one important result of continuity also. Okay, so we'll begin with that. But before starting, let me tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform, and you can prepare for many exams on this platform. So for IIT-JEE, you can take two types of subscription. One is plus subscription and other is iconic subscription. And other than that, you can also watch free videos on YouTube and special classes on Unacademy's learning app, which are completely free, and many quizzes and tests you can attend without having any subscription, without paying anything. All right. So there are a lot of stuff which you get for free also, like these YouTube classes, live classes you can attend, and cover a lot of topics on physics, chemistry, and maths. So this is one of the channel of Unacademy in which you can you can prepare for your IIT-JEE. All right. But if you want to uh, attend the sessions of all the top educators on Plus, then you'll have to take the subscription. And I'll tell you about that subscription. So if you take Plus subscription, then first of all, you get access to daily live classes of all the educators who are teaching on Plus, Unacademy Plus. All right. All means all physics, chemistry, and maths. So all India's top educators are teaching there, and you can follow any educator. You can follow any educator's course of your choice. Okay, so you can study from your favorite educator on an Academy Plus by taking the subscription. Every course is well structured. Every lecture is pre-planned, so you get to know the schedule. You can see the schedule of all the educators in well advance. So whatever topic, date wise, time wise, and topic wise will be visible to you once you have the subscription. So you can see the schedule. All right, all the courses accordingly. You can plan your this studies. Second, all live tests and quizzes, all India test series will also be accessible. So in short, if I tell you that if you take the Plus subscription, then you get unlimited access on the platform. Okay, there's nothing which will be left. So you can watch, you can follow any educator. And about these live classes, if you miss something, then all the classes are recorded also, so you can watch them later. You can download, even you can download them and watch them offline. All right. And then these live classes are very interactive. You can ask your doubt during the live classes also. You can chat with your educator. You can participate in poll. All right. So to get the feel, you can attend special classes. As I told you, special classes are completely free. So you just download the app and make your account. No need to take any subscription. No need to pay anything. You can attend the special classes. These are exactly the same, which we which you the classes which are going on Plus. All right, exactly same. So those classes are like well structured courses, and special classes are like a special class on a particular topic by some educator. Okay, so every educator plan special classes on various topics. Okay, so you can attend those classes also. Every day you can see a lot of special classes are going on for physics, chemistry, and maths. If I talk about IIT-JEE, and you can attend any special class of your choice, and this is also unlimited. All right, so this was about Plus subscription and about the platform. If you want to take Plus subscription, then these are the subscription charges. You can buy it for 1 month, 3 months, 6 months, 12 and 24 months. 3 month subscription is of 70,000, 70,500. 6,000 is 6 months is 28,000, and average you can see per month is 4,667. 1 month it is 7,000. All right, so 12 and 24 months are good subscriptions which you should take, because per month price, if you compare, is around more less than the half of 1 month subscription. All right, which is of 7,000. So in 12 months it is going to be 3,200, and that too you can get 10% off if you use my code Jeet1. So finally you'll have to pay this much per month, 2,888. All right, so it is 34,650 for 1 year. All right, and 50,400 for 2 years. And in this you can see average per month is just 2,100. All right, you also get option of no cost EMIs. Okay, for 6 months and above subscriptions. If you're buying 6 months or above subscription, like 1 year, 2 years, then you have no cost EMI available. Okay, now about this iconic subscription. You get all the benefits of Plus. Whatever you are getting on Plus, you will get the same benefits on iconic subscription also. All right, all the benefits. And apart from that, you'll get a personal coach. Okay, personal coach who will guide you throughout your top exams like IIT-JEE Advanced, Main, and BITS. Okay, so you'll get a personal guidance of an expert. That is an additional feature in iconic subscription. Additional feature, I'm saying, because you get all the benefits of Plus in iconic subscription also. Apart from that, your test analysis will be done in a personalized manner. The personalized feedback will be given to you to improve your time management and exam approach. Your study planner will be customized, and bi-weekly reviews will be given to you, highlighting your progress. All right, so this is about the iconic subscription. You can buy this iconic subscription for 12 months or 24 months. 12 months it is 56,000, all right, and after 10% discount it will be of 50,400, and for 24 months it is of 86,000, and after 10% discount it is of 77,400 only, right? Now let's yeah, this is Unacademy's learning app, which you can download from Play Store. All right, Unacademy's learning app. Now let's begin our session. All right. So as I told you, there was one point remaining in continuity. First, I'll cover that, and then we'll discuss differentiability. So the point was that if f(x) is discontinuous at x is equal to a, but discontinuity of finite type, not infinite type. Okay, discontinuity of finite type. Let me define it as, let me write it clearly. You can say RHL, LHL and f of a are finite. Okay, finite but unequal. Okay, any two of, at least two of them are unequal, but they are finite. Okay, that is the important point. That is like greatest integer. Greatest integer function has discontinuity at all integers. Say at x is equal to 1, right hand limit is 1, left hand limit is 0, and value at 1 is also 1. So this function is of the type which we are talking about. Okay, yeah. So fx is discontinuous at x is equal to a, and RHL, LHL, and f of a are finite but unequal. Okay, and gx is a continuous function. At x is equal to a. Okay, gx is a continuous function at x is equal to a. Then, all right, now listen to this carefully. Then fx into gx will be continuous at x is equal to a, provided g of a is equal to 0. Now that is a very important point. Okay, otherwise discontinuous. Okay, otherwise discontinuous. So this is the important point which I was talking about. So like let me give you one example. Like fx is equal to x minus 1 into greatest integer of x. All right, check the continuity. At x is equal to 1. You know, I just gave you this example. Greatest integer of x is discontinuous at x is equal to 1, but left hand limit, right hand limit, and value, all three are finite. And x minus 1 is a continuous function with value at x is equal to 1, 0. X minus 1 is 0 at x is equal to 1, right? So that means this greatest integer is multiplied to a function which is a continuous function, and its value at x is equal to 1 is 0. Okay, so this will make the product continuous. All right, if you check at 1, right hand limit, that means h approaching to 0, it is 1 plus h minus 1, and then greatest integer of 1 plus h, so it is going to be h only. Now h is approaching to 0, so this is 0. You can see if you find left hand limit, so left hand limit is h approaching to 0, It is 1 minus h minus 1, greatest integer of 1 minus h. So greatest integer of 1 minus h is itself 0, and this is also 0, so 0 into 0 is 0. And value f of 1 is 1 minus 1, which is 0, and now 0 is multiplied to any finite or number, it is going to be 0 only. So you can see left hand limit is equal to right hand limit is equal to value at 1. All three are 0. Okay, but check at x is equal to 2. Now check at x is equal to 2 for the same function. Okay, so now at x is equal to 2, x minus 1 is not 0, although it is continuous, and this function is discontinuous. So greatest integer function is discontinuous at x is equal to 2, and x minus 1 function is continuous at x is equal to 2, but x minus 1 is not 0. That means this function is not going to be continuous at x is equal to 2. All right, so let's check it. If I check first of all f of 2, so f of 2 is going to be 2 minus 1 into greatest integer of 2. Yeah, I'll repeat it. Let me give this example. So this is 2 only. Okay, I'll repeat it. Now listen to this, Raghav. So the important point about the continuity was if fx is discontinuous, देखो, fx is a discontinuous function at x is equal to a, ठीक है? Such that its left hand limit, right hand limit, and value are finite. All three are finite but unequal. Okay, so that kind of discontinuity it has. It should not be infinite, because in case of infinite type of discontinuity or missing point, we won't be able to say anything. All right, but in this case, when left hand limit, right hand limit, and value all three are finite, then we can use this point. All right, so fx is a discontinuous function at some point a with left hand limit, right hand limit, and value at a having finite values. Okay, I mean these values are finite but unequal. And gx is a function which is continuous function at x is equal to a. Then we are talking about the continuity of fx into gx. Okay, fx into gx. So I'm saying that fx into gx will be continuous at x is equal to a, provided g of a is equal to 0. That means ये जो continuous function है, the continuous function इसकी value अगर a point पे 0 हुई, then this will make fx into gx continuous, because ये 0 multiply होगा to left hand limit, 0 multiply होगा to right hand limit, and 0 multiply होगा to f of a. So all three values will become 0, right? But if gx is continuous but not 0 at a, then it will remain discontinuous. Okay, so I gave one example based on this. X minus 1 into greatest integer of x. Okay, we need to check the continuity at x is equal to 1 for this function. We know that greatest integer function is discontinuous at 1, but it has finite values, left hand limit, right hand limit, and value. All three are finite, okay, but discontinuous. And x minus 1 is a continuous function with its value at 1 is equal to 0. 1 पे इसकी value 0 है, right? इतना clear है? So by looking at this and using the point which I have just told you, we can directly say that it is continuous at x is equal to 1. Okay, it is continuous at x is equal to 1 because greatest integer function is multiplied to a function which is continuous as well as its value is 0 at x is equal to 1. So यहाँ मैंने calculate भी किया है. Right hand limit I have calculated 1 plus h minus 1 into 1 plus h. So it is, this is 1 and this is 1. This is h, this is 1. So h into 1 is h and h is approaching to 0. Now second, it is 1 minus h, left hand limit 1 minus h minus 1, and greatest integer of 1 minus h. So this value is greatest integer of 1 minus h is 0. So it will make the product 0. And anyways, this second value is also 0. Okay, so 0 into 0, 0. And third, f of 1 is 0 into 1, which is 0. So you can see left hand limit is 0, right hand limit is 0, and that was the point actually. The function which we have multiplied is having value left hand limit, right hand limit, and value all three 0. So when it will be multiplied to fx function which was discontinuous but having finite values, so it will make all three values 0. Okay, but for the same function, if we check at x is equal to 2, okay, at x is equal to 2, ये मैं discuss कर रहा था. When we'll check at x is equal to 2, then f of 2 will be 2. Okay, now at x is equal to 2, we can directly say that it is going to be discontinuous. Why? Because greatest integer function is discontinuous. This is discontinuous, and this is continuous but non-zero, but not equal to 0, right? So there's no point of multiplying a continuous function which is not 0. It won't make the function continuous. Okay, देख लेते हैं. So f of 2 is going to be 2. F of 2 plus h is also going to be 2, because it is going to be 2 plus h minus 1 into greatest integer of 2 plus h. So this value is 2 and this value is 1, so it is 2. All right, and but left hand limit is going to be different, 2 minus h. Okay, so 2 minus h is 2 minus h minus 1, and this greatest integer of 2 minus h is 1. This value is 1, this value is also 1, so 1 into 1 is 1. Okay, so you can see this left value is different. All right, LHL same nahi hoga. Yes, have you got the point? Have you got the point, beta? Let's use this point. Okay, let's use this point. I'm giving you one very good example. Okay, so find the number of points where this fx function is continuous. Okay, so my first example is, okay, and number of points, and also write the point. Okay, in these examples. All right, let's do these 3 examples first. Let's find points in first function. And what is that point? At x is equal to 1, it is discontinuous or continuous? All right, yeah, Vamsi, your answer is correct. X is equal to minus 1. Actually, see, signum of x square minus 1 is discontinuous at 2 points. Okay, signum of x square minus 1 is discontinuous at x is equal to plus minus of 1, right? You see, अगर 1 पे check करेंगे, signum of x square minus 1 is basically, and it has finite values. This will be positive, yani plus 1. When x is greater than 1 or less than minus 1, it will be minus 1, between minus 1 and 1, and 0 at these points, okay? So when this function is multiplied to x minus 1, so it will make function signum of x square minus 1 continuous at x is equal to 1, because ये जो function हमने multiply किया है इसकी value 1 पे 0 है, right? And it's a continuous function. तो ये 0 0 0 जब इनसे multiply होगा, this value will be multiplied to 0, this value will be multiplied to 0, so 0 into 1, 0 into minus 1 will become 0 only, right? And so continuous at x is equal to 1, but at x is equal to minus 1, it will be discontinuous, because signum is already discontinuous and it is multiplied to a function which is continuous at x is equal to minus 1, but it is not 0, okay? So minus 1 paid is not 0. So, and discontinuous at x is equal to minus 1. Have you got the point, Raghav? Yes, nice, Vamsi. Okay, now try second one, okay? Yeah, is a function which is multiplied, a continuous function which is multiplied to a discontinuous function. एक function discontinuous है और एक continuous है. तो जो continuous है ना, that should be 0 to make the product continuous, okay? But if that function is not 0 at the point where the second function is discontinuous, तो फिर product will not be continuous. It will be discontinuous. It will remain discontinuous, okay? Yeah, that is the logic. Are you getting the second one? Have you got any answer of second? Yeah, Vamsi is saying always continuous. What's your answer, Raghav? Where is this function? How many points are there where this function is discontinuous? Answer might be infinite also, okay? You can answer infinite also. Like 1, 2, 3 or infinite number of points. All right. Yes. So both of you are correct. Very good. It is always continuous because this function is discontinuous at all integers, right? कितना प्यारा example है. And this function is always continuous always continuous, and its value is 0 at all integers. All right, when you put x is equal to 0, 1, 2, 3, the sine theta is 0 when theta is n pi. So theta is pi x, so pi x is equal to n pi, that means x is equal to n. So it is 0 for all integers, right? So it will make this greatest integer function continuous, right? Because every time around integer you are multiplying this greatest integer function by a 0. Okay, so it will always be continuous. A very, very good example. Got it? All right, it's always continuous. What an example, huh? And it's if you plot the graph, then it is going to be like this. So graph is also very interesting. See, 0 to 1, this is 0, right? So overall function will be 0. I'm just plotting the graph right hand side of origin. So 0 to 1, it is going to be 0. Now 1 to 2, at 1 it is 0, so 1 pe b value 0 rahegi. Now 1 to 2, this function is going to be 1, okay? So it will become sine pi x. So you need to draw the graph of sine pi x between 1 to 2. So between 1 to 2, it is going to be this sine pi x, okay? Now 2 to 3, this will become 2, and this is sine pi x only, so 2 times of sine pi x. So sine pi x ka jo magnitude hai, that will increase. Now it will go up to 2, right? Like this. Now 3 to 4, it is going to be 3 now. So ye wala value kitna hua? This peak is now 2, right? This peak is now 2. This peak was minus 1. Now it will go up to, now it is multiplied to 3, so it will go to minus 3, okay? So that will go to minus 3, and then again it will go to plus 4, the next interval 4 to 5, right? Like this. Are you understanding this? 4 and 5. So that kind of graph will be there of sin x function, okay? Increasing sinusoidal, very, very nice, okay? It's like this. So that is what is happening here, and you can see ki we'll talk about differentiability later, okay? That's with the same example we'll talk about differentiability. Now answer this third one, okay? Third one. Two and 1. You're getting 2 points. You're getting 2 points. Two points of discontinuity. Vamsi is getting 2 only, okay? 2 only. Yeah, it's actually 2 only, yeah. Yeah, ln1 is 0. That was the point. That's why we have multiplied by ln1, okay? So when you multiply it by ln1 is ln x is continuous for x more than 0, and ln 1 is equal to 0. So, and this signum of x square minus 3 plus 2, this function is discontinuous at x is equal to 1 and 2, and you know signum of any number is always, any real number is always finite, either it is +1 or -1 or 0. So signum will always have that kind of discontinuity, which is the condition for our point. Okay, so signum of x square minus 3x plus 2 has discontinuity at 1 and 2, but 1 value discontinuity will vanish because of ln x, because ln x is 0 and x is equal to 1. So only point where this function will remain discontinuous is 2. So this f is discontinuous at x is equal to 2. Have you got the point? समझ आ गया? Or if I can you multiply this function, this third वाला जो है, इसमें can you multiply another function to make it always continuous? Now you need to give me one example. Okay, what function shall I multiply to this? There are infinite number of functions. You tell me one function, any one, okay, which should be multiplied to this so that it will become always continuous for all positive values of x. Okay, tell me one example. Which function we should multiply to this? ln x into signum of x square minus 3x plus 2. You can give any example. Tell me, Raghav, which function shall we multiply? Function, which function shall we multiply? Like you have multiplied ln x, similarly you need to make one more function, you need to multiply one more function of x, which will make this overall function differentiable at continuous at 2 also, because 2 is the problem, no? If I write gx is equal to, no, not signum of, why signum of x minus 2 is already discontinuous. You should multiply by a continuous function, no? Signum of x minus 2 तो discontinuous है. You should multiply by a continuous function whose value at 2 is 0. Then that will make this function continuous, na? Remove this signum. You should multiply by x minus 2. Okay, this is one example. You can make any other example. You can take any other example. X minus 2 ln of x and signum of x square minus 3x plus 2. Now see, because of this x minus 2, this function is continuous. Because of ln x, this function is continuous at 1, and because of x minus 2, this function is continuous at 2. So now it is continuous for all values of x. Okay, so this is always continuous for x more than 0. Are you getting this point? Have you got it? You could multiply by sine pi x also. You could multiply by x square minus 4 also. Okay, any function which is 0 at x is equal to 2, as well as continuous at x is equal to 2. Okay, are you okay? Now I'll give you last two examples for continuity. Okay, then we will continue with differentiability. So last two examples. Okay, fx is equal to do it carefully. x square minus 9. The last point is x square minus 9. Okay, this is our last example. Okay, in this I have clubbed two three important points together. Find the number of points where f is discontinuous. Three and two. These are the points. All right. Let's check. That means you're getting 2 points. Okay. Uh, this function. What about this function? Mod of a continuous function is continuous, right? Because of mod, there's no problem in continuity, right? There's no problem in continuity because of modulus function, right? Is it okay? So this is always continuous. Now, this e raised to x square minus 1 is continuous and 0 at x is equal to 0, right? This signum of x square minus 2x is discontinuous. We know where signum function is continuous, where this function becomes 0. At x is equal to 0 or 2, right? At these 2 points. But 0, this point, okay? This point will not be point of discontinuity because it is multiplied to e raised to x square minus 1. So overall this function will be discontinuous at x is equal to 2 only, okay? So 2 is the only point where this function is discontinuous. Now let's come to this point, signum of x square. So this signum of x square minus 9, you both have got it wrong, huh? This function is discontinuous at x is equal to plus minus of 3, all right, plus minus of 3. But sine of yx is always continuous, first of all, always continuous, and 0 for all integers. 0 for all integers. Okay, 0 for all integers means how many points are remaining, because plus 3 and plus 3 and minus 3, plus 3 and minus 3 are already integers. So sine pi x will be multiplied to signum of x square minus 9, and it will make it continuous always, because problem was at 3 and minus 3, but sine pi x is continuous and it has value 0 at 3 and minus 3 also. So it will remove that problem of discontinuity. So the only middle function, the beach wala jo function is second one. Okay, this expression. This has only one point of discontinuity, and that point is x is equal to 2. All right, and then first and third expressions jo hain, they are always continuous. Okay, so you know, when we add one continuous and other discontinuous, then continuous plus discontinuous is this discontinuous, right? So because first and third continuous hai, for वाला discontinuous है, so point of discontinuity will be at x is equal to 2. In addition, we have already done that, right? If one is continuous and other is discontinuous at x is equal to a, then their sum or difference will be discontinuous at x is equal to a, right? So using that, we can say that x is equal to 2 is the point of discontinuity. I hope it is clear now. So we are done. Now let's continue with differentiability, shall we? Okay, differentiability. Okay, so सबसे पहले first let's understand one point where this function y is equal to fx is not differentiable at a point x is equal to a if its graphically we are checking the differentiability. If its graph is corner or cusp at x is equal to a, this is called cusp. This is called cusp, and like this is a corner, or maybe this is a corner, right? This is a cusp, this is a corner, this is a corner, right? So let's take one example. Say y is equal to fx. Graph of y is equal to fx is like this. Say it is coming like this, okay, and then suddenly it becomes like this. All right, then it goes down and again it suddenly changes its slope, right, like this, and it is smooth everywhere and like this, and then it becomes a straight line like this. Okay, so you can see this function is problem at many points. At this point, say this is x1. At this point, say this is x2. This point, say this is x3. All right, and this point looks okay. I'm making a corner here. Okay, making a corner here. So corner means slope is suddenly changed. If you find the left hand derivative, you know the first definition. If you join this point to its left side point, then tangent will be left hand derivative will be slope of this line, right? And if you join the same point at x1, f of x1, to its right side point, okay, point which is right side of this, so its ka slope jo hoga, this will be in this direction, right? So obviously you can see this will be the left hand derivative, slope of this line, and slope of this line will be the right hand derivative. Okay, so because of this corner, you can see these left hand derivative and right hand derivative will not be equal even if you apply first principle. Although in such cases no need to apply first principle, you can directly answer it, like by putting modulus function you get a corner in many of the questions, right? Is it okay? So this is a problem, this is a problem, this is a problem. Okay, now we will try to understand the questions or functions where we can apply this concept directly, where we can apply this graphical corner and cusp or kink, right, directly. So first of all, let's understand modulus function. What does this modulus do and what is happening actually? See, when you put mod on fx, then graph, okay, say this is the function, and its slope at x is equal to, say, this point x1, where this is passing through x-axis, is not 0. This slope is say m. Okay, this slope is m, slope of tangent. Are you following? Are you understanding? Okay, so I'm taking a function whose slope at the point where it cuts x-axis is not 0. Okay, it is some non-zero number. Raghav, are you understanding? This is y is equal to fx. Okay, but when you put y is equal to mod of fx, if you put mod on f, then what happens? This portion, which is this going down, this will come up. This will come up like this. So you can see it. This slope was m. The slope of this line will be minus m. You know this, right? If slope of this line is m, if this angle is theta, and its slope is m tan theta, then slope of this line will be minus m, because this angle will be pi minus theta, right? So now its slope is minus m, and m is not equal to m, so this is going to be your right hand derivative, this is going to be your right hand derivative, and this is going to be your left hand derivative. Okay, so now left hand derivative is not equal to right hand derivative. That means now you can see a corner here. This is a corner. Okay, corner if m is not equal to 0. Are you understanding this? Okay, are you understanding this? Like, for example, if I put mod on, say, x minus 1, okay, this is pretty simple, but we'll start with simple examples. This is y is equal to x minus 1, right? You know that this is y is equal to x minus 1. If you put mod, then this line will come up like this, and you can see a corner now. You can see a corner because slope of this line was 1. Now slope of this line will be minus 1. So if you try to find the right hand derivative, then that is going to be 1, and left hand derivative is going to be minus 1. Are you okay? Okay. But if I take another example, let's take one more example. Y is equal to x square minus 1. This is x square minus 1, right? This is x square minus 1. So you can see slope is not 0 at 1 and minus 1. So when you put mod on this, then this was the graph of y is equal to x square minus 1. This is plus 1. When you put mod, then graph is going to be like this, right? So now this function will be non-differentiable at x is equal to 1 and minus 1. All right. So when you put mod, generally function becomes non-differentiable, but it's not always true. I'll give you one more example. So far, it is okay. Now I'll give you one more example. What about this function? Tell me the differentiability of this, or this. Same thing. They both are same. Tell me, Raghav, Vamsi. 2 points. Mod of x cube 2 points. And what are those points, by the way? What are those points? See, this is the graph of x cube. This is the graph of x cube, okay? Now try to understand this. This is the graph of x cube. Okay, only one. Now listen to this. This is y is equal to x cube. What is the slope of x cube at x is equal to 0, by the way? What is the slope? If you take, what is the slope, Raghav, of y is equal to x cube at x is equal to 0? Slope of tangent at this point? 0. 0. So when you reflect this curve, when it comes up after applying mod, then they will join each other, left hand portion and right hand portion. They will join each other with same slope, because right hand side this slope is 0, slope of tangent, and this slope is also 0, minus m. So minus m is 0 and plus m is 0. So it will be only discontinuous if graph is crossing the x-axis at some non-zero slope. But if it is crossing the x-axis by touching it, then after reflection, I mean after putting mod, it won't be non-differentiable. It will be differentiable. They are joining each other smoothly. That means if two curves join each other smoothly, say slope of this curve is at this point, say this is fx, okay, and its slope is m, and it is joined to another curve gx. After this gx starts, and they are joining each other with the same slope, okay, and same value. This slope is also m. Then this is not a corner. They are joining each other smoothly. All right. This is gx function. So at x is equal to say a, this function is going to be differentiable, continuous and differentiable. They are joining each other and they are of same slope. So that's what is happening here. At this point, left hand this function which is minus x cube and this function which is plus x cube, they are joining each other at 0. Okay, it's continuous and their slopes are 0, left hand side and right hand side. So it will remain differentiable. Okay, there's no problem in differentiability of this function. So just by putting mod, it's not like signum function that signum put किया और non discontinuous हो गया. Mod put करने से it may be or it may not be. You'll have to check the slope at that point of the, okay. देखो, I can write like this. If fx is continuous at x is equal to a such that f of a is equal to 0, all right, then mod of fx, okay, mod of fx continuous and differentiable also, okay, differentiable, then mod of fx will be see, two answers, will be differentiable if f dash a is equal to 0 and non-differentiable if f dash a is not equal to 0. Have you understood? I've written this point here. No, it's not Rolle's theorem. No, nothing to do with Rolle's theorem. I'm just saying कि mod को put करने से differentiability कब change होती है. A function जो कि x axis को cross कर रहा है, It is differentiable, that means its graph is smooth by after putting mod, because नीचे वाला पोर्शन ऊपर आएगा तो क्या वहां पे कॉर्नर आएगा, or will it be smooth, will it remain smooth? So it will remain smooth if its slope at that point was 0, like in this example. Okay, but if you talk about some other function, like function is like this, which is not touching x-axis, so in this function if you put mod, then there will be a corner, you can see this is a corner. मॉड के बारे में बस डिस्कस हो रहा है यहाँ पे, मॉड ऑफ एफ एक्स में क्या होगा, टेल मी नाउ. मॉड के बारे में. ओके, नाउ आई टेल यू वन एग्जांपल. ओके, नाउ यू नीड टू आंसर y इज इक्वल टू, समझ आया ये, हैव यू गॉट इट? इफ यू गॉट इट देन आई विल गिव यू वेरी गुड एग्जांपल. माइंड घूम जाएगा तुम्हारा. mod of x minus 1 whole square, x minus 2 into x minus 3 whole cube into x minus 4 whole mod. Okay, discuss the differentiability. Find the points where y, I mean fx, this function, let's take this fx, where fx is non-differentiable. See the graph. I think you should learn the graph of this. It's a polynomial factorized form. It's very easy. I'll tell you This point is 1, this point is 2, this point is 3, and this point is 4. Okay. So if you draw the graph of, just plot the sign first of all, the sign will be positive and the sign will change. Then the sign will change again because of what power, like very curve method. But two baby sign change over and one baby sign change over, right? Like this. So if you plot the graph of this polynomial, which is odd degree polynomial, you can see it will go to infinity because infinity पे polynomials की values infinity and minus infinity होती हैं. So minus infinity because of this sign, you can see it will be minus infinity. So graph will come from minus infinity. Graph of this polynomial, I'm plotting this polynomial. Y is equal to x minus 1 the whole square into x minus 2 into x minus 3 the whole cube into x minus 4, right? Okay, so graph will come from minus infinity और जहाँ पे repeated roots होते हैं, like x is equal to 1, you have repeated root, then their graph of fx will touch the x axis. मतलब वहाँ पे उसका slope भी 0 होगा, dy by dx भी 0 होगा. And one more point, if it touches the x axis, then touch करने के बाद it will return voice problem. Hello. Oh, all right. Is it good now? Check. Is it good now? Better. No. Sorry. Change. Let me check. Hello. Okay, I'm restarting. Okay, so I'll continue after. Hello. 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 Yeah. Hello. Now is it good, Raghav? Are you there? Okay, clear. Then see, I was telling you that it will touch. Okay, देखो क्या होता है, whenever a function has repeated root, say this is alpha, okay, then x minus alpha raised to n. So if n is even and graph is coming from downwards minus infinity, it will touch at alpha and it will go down only. Okay, मतलब sign change नहीं होगा. Like in this you can see minus sign is on the left side as well as on the right side of 1. So if it is coming from minus infinity, then it will touch at x-axis, touch the x-axis at 1 and it will go down only. Okay, if it is coming from up, then it will touch at 1 and will go up. Okay, if n is even, this is the case when n is even and repeated root, right? And n is more than 1, of course. And if n is odd, then graph will again touch, like graph n is odd but more than 1, then it will again touch the x-axis like this only, but it will cross the x-axis, like in the case of x cube. 0 was the repeated root 3 times, so it touches the x-axis as well as it crosses the x-axis. All right, have you got these 2 points? This is when n is odd and n is more than 1. All right, in both the cases it is touching the x-axis. All right, Raghav. So graph will come from minus infinity, it will touch the x-axis at 1, it will go down, then it will again come back to x-axis at x is equal to 2, and now it will cross because 2 is not the repeated root. Okay, 2 is not the repeated root, so 2 पे cross करेगा, and then x is equal to 3, again it's a repeated root but odd power, so it will touch the x-axis as well as it crosses the x-axis. You can also see this sign, that's why हमने sign पहले बना लिया. So graph is crossing the x-axis. Now again it will come back to x-axis and will meet the x-axis at 4 and it will cross because 4 is not the repeated root, तो 4 पे touch नहीं करेगा, किसी angle पे cross करेगा, non-zero angle पे. Now tell me, so slope is m is equal to 0 here, m is not 0 at this point, m is 0 at this point, m is not 0 at this point. Okay, so if I all right, so if you put mod of fx, then this graph will come up, right? Reflection like this. This will also come up, so it will touch, and now you can see here it will be a corner. Okay, this is a corner, this is a corner, and then it will be, now this part will reflect, this part will reflect again, so after reflection it is going to be like this only, and here again you can see corner. So corners will be only at these 2 points, this, so points of is it with your net, because I can see from my side there's no problem now. Okay, the points which you miss, have you got this point? So f is non-differentiable at x is equal to 2 and 4. Okay, तो ये ग्राफ है, पॉलिनोमियल का ग्राफ बनाना था एंड देन वी हैड टू डू इट. अब थोड़ा कस्प की बात कर लेते हैं. ओके, कस्प कैसे आता है? सी y is equal to, I am taking these examples. Okay, these are very important examples. Is your net stable now? P upon Q, this type of function. Net stable है तुम्हारा? All right. We'll do this tomorrow 11 a.m. Okay, 11 same time. Today's evening session you can see will be conducted tomorrow at 7 p.m. All right. It's okay, no problem. I actually have another session also that I'll start in some time. Okay. Anyways, I was about to finish after 5 minutes. Okay, well, this part we'll do in next session. All right. So thank you very much for watching this. Like and subscribe. कल मिलते हैं.